Hello, hi, Embedded System Part 4. I welcome you all to Saijani Academy channel. Today, we are going to discuss on characteristics of embedded system, embedded softwares. Let us start with small definition. Any device that includes a computer but is not itself a general purpose computer. It has hardware as well as software, part of some large system and expected to function without human intervention. An embedded system is expected to respond, monitor, as well as control external environment using sensors and actuators. Now we'll see some of the characteristics of embedded system. It is a single function, executes a single program repeatedly. This is the embedded system. Tightly constrained. It means it's a low cost, low power consumption, small in size, faster, high speed. Reactive and real time. All embedded systems are not real time. Reactive means continually react to the changes in the system's environment. Must compute certain result in a real time without delay. Next one characteristics is application specific functionality. Specialized for one or one class of applications. This is the most important. Deadline constrained operation. System may have to perform its function within specific time period to achieve successful result. Next, power efficient. Many systems are battery powered and must conserve power to maximize the usable life of the system. Manufacturer means usually small and inexpensive to manufacturer based on the size and low complexity of the hardware. So, in a summarized manner, the speed bytes per second should be high speed, power in watts, low power dissipation, size and weight as far as possible small in size and low weight. Accuracy in percentage of error must be accurate. Next point is adaptability, high adaptability and accessibility. Reliability must be reliable over a long period of time. These are some of the characteristics of embedded system. Now we move on to embedded software. Software for an embedded system interrupt physical work, therefore definitely takes time, it consumes power and it does not terminate. Definitely it takes time. So there is a issue of time consumed by software in relation to the timings of the external event. It consumes power. We have to think in terms of designing software which is power efficient. It does not terminate. Unlike standard program where the expect to terminate is infinite number of steps, this program typically do not terminate. So it takes time. Definitely embedded system means it takes time, it consumes power, it does not terminate. These are the 3 points is the software. Embedded software hidden in watches, VCRs, cell phones, toasters, guided missiles, control satellites, used in medical instruments. All are the software which are hidden. Requirement of software for embedded system? Reliability. The most important one is reliability. Because human intervention not possible for error handling, they expected to run without human intervention for a longer period. This is the reliability. Cost effective. The cost must be low power consumption. Performance requirement is timeliness. Physical processor are concurrent. Concurrency means what? Embedded system engage physical world where multiple things happens at once. Liveness. Program must not terminated or block waiting for event that will never occur. Interfaces. When we build up a software, we have to do kind of composition, reuse of a component. Components combined according to the interface based upon the static behavior. There would be dynamic behavior also. Heterogeneity, different computational style and implementation technologies. Interact with the event occurring, irregular in time, say for example alarm, user's command, sensor triggering, etc. Regularly in time, sampled sensor data and actuator control signals. Next goes to the reactivity. Reactivity means react continuously to their environment at the speed of the environment. That is very important. Safety criticals. Reactivity means reacting to external environment. Since it is reacting to the external environment, obviously there will be bounds in the response time. What do you mean the response time? The time between presentation of a set of input to a system and the realization of the required behavior, including availability of the associated outputs, is called response time of the system. Real times. What do you mean the real time? When there is an external signal coming in corresponding to the characteristics of the external signal, there will be the bound on response time, and that leads us to formal definition of real time. Real time system is a system that must satisfy explicit bounded response time constraint or risk severe consequences including failures. Here is some of the example we have represented here. This is the flight control system. This is called as hard real time. Another example is avionics, and this one is data acquisition system is for soft real time. Another example for a soft real time is ATM, where response time is not important. For example, in a ATM, there may be delay in delivery of cash or delivery of the receipt, but delay is not critical. It is true for typical DVD players as well when it is decompressing video frames for playback. So these are the examples for soft real time system. These examples for hard real time, where time bound response is required. Here time bound response is not required, because if you go to ATM, you are waiting for the money, you are putting the numbers, you are putting the card, then you will wait for the response, and then you click onto the some buttons, for transactions, taking money or putting the money in the ATM machines, where you will wait. These are not actually hard real time. These are the soft real time. Time is not in a bound. Next, we discuss hard real time. Another example for hard real time is awareness. This is the weed killing machine is the example of firm real time. So real times are classified into hard real time, soft real time, and firm real time. In hard real time, the time bound is very important. It has only one deadline. If you miss that particular deadline, entire system is get collapsed, or we say catastrophic failure. In case of firm real time, say this is the firm real time system. This is the weed killing machine is the example for firm real time. We are using some robots to pick or to kill the weed which is there in the crop. So these machines are, they can miss one or two. By miss they can pick instead of weed. They may pick the original crop. It is not a big point. Instead of picking the weed, it always remove the crop. Then what happens? The entire system get failed. So it means the whole system is get failed. This is called as catastrophic failure. This is the hard real time data acquisition system or ATM for soft real time system. Then we have avionics. Then we have a missiles guidance system is for real time system. You must note that all embedded systems are not necessarily real time system, and there are some systems which are real time. For them the time bound is critical. Okay, categories of real times. A soft real time system is one in which performance is degraded or delayed but not destroyed by failure to meet the response time constraints. Example, ATM machine. Soft real time example is automatic teller machine. Next one is hard real time. Hard real time system is one in which failure to meet a single deadline may lead to complete and catastrophic system failure. Example, avionics weapon delivery system. Because after decider press a button to release the weapon, from that point actual delivery should be bounded. Otherwise, the target would be missed. Then whole purpose releasing a weapon is lost. This is the hard real time system. So we have given a avionics system. Firm real system. The firm real time system is one in which a few missed deadlines will not lead to a total failure, but missing more than few may lead to complete and catastrophic system failure. Example, navigator controller for a robot weed killer machines. So these are the reference. Thanks for watching this video. Please subscribe our channel. Thank you.